All right, welcome to 8th grade, lesson 2.1, integer exponents. Our objective today is I can use properties of exponents to solve problems. So we're going to look at using exponents in new ways and combining them. Really quick, I want to review exponent patterns so we remember how exponents work, even though we just looked at our pre-module review. I'm going to start with 10 to the 0 power. I'm going to start here in the middle. Remember, anything to a 0 power is going to be 1. I'm going to go to the left. If I have 10 to the first power, that really just means I have 10. If I have 10 to the second power, that's 10 multiplied by itself twice, 1, 2. 10 times 10 is 100. If you remember our cheat from earlier, when it comes to using 10 as a base, the exponent tells us how many zeros we have. So I don't have to multiply every time. I can just know that I have 3 as my power, which means I'm going to have 1, 2, 3 zeros. Now, on the other side, we have 10 to the negative 1. And we remember from our previous review, that just means we have 1 over 10. 10 to the negative 2 is going to be 1 over 10 to the second power, which means we just have 2 zeros underneath. Now, what does that look like with non-10 base? Well, let's start in the middle. 3 to the 0 power, anything to the 0 power means that it's going to be 1 every time, regardless of the base. To a 0 power means 1. 3 to the first power, that just means I have 1, 3. 3 to the second power means I have 3 times itself twice, so 3 times 3. 3 times 3 is 9. 3 to the third power is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. We're going to go back over here to our negatives. 3 to the negative 1 is just going to be 1 over 3 to the first power, which is going to be 1/3. 3 to the negative 2 is going to be 1 over 3 to the second power, or 1 over 9. Oh, all right. Let's go ahead and look at some properties of exponents. We're going to look at a couple different things, and then we're going to look at the rule for those things. Okay. So, properties of exponents, we're going to start with multiplying with the same base. So, same base means that the number that we're multiplying is the same, 4 and 4. So here we have 4 to the third power times 4 to the sixth power. To do that, we are going to follow this rule. And this is going to look a little bit wonky. A represents our base. Our first number is to a power, x. These letters are representing any number. So for example, we have 4a to the third power, x. We are multiplying that times 4, the same number, so I'm going to use the same variable, to the sixth power. This is a new number, so I'm going to use a new variable. And this is equal to a to the x plus y. This can look kind of stressful. Here's what that means. When we are multiplying with the same base, we add our exponents. That's it. I don't have to do 4 times 4. I can do 4 to the third plus 4 to the sixth here. I'm just going to add my exponents. And here's why that works. I have 3 4s here. 4 times 4 times 4. I'm multiplying 6 4s. 1, 2, 3, 4, 5, 6. Altogether, these are all multiplication symbols, so altogether I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 4 to the 9th power. So when we have same base, different exponents, we can really just add our exponents and keep the base the same. Let's look at it with a 7, for example. 7 to the 2nd, 7 times 7, multiplying by 7 to the 5th, so that's 1, 2, 3, 4, 5. 5 plus 2 is 7, so this should be 7 to the 7th power. 1, 2, 3, 4, 5, 6, 7. There we go. So when you're multiplying with the same base, we're just going to add exponents. So add exponents, keep base. All right. Let's look at division. When we're dividing with the same base, let's say we have 5 to the 7th power over 5 to the 3rd power. I'm going to do the example before the roll this time. I'm going to write it out. 5 to the 7th power is 7 5s. 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, 7. Divided by 5 to the 3rd power. 1, 2, 3. If you remember from way back 6th and 7th grade, if you have a number over itself, that makes a 1. 1 times anything stays the same, so we can essentially cancel some of these things out. We can cancel out a top and a bottom until we are just left with this. Notice there's nothing left on the bottom, which means we just have 5 to the 1, 2, 3, 4. Which is the same as 7 minus 3. 7 minus 3 is 4. Let's look at it with the 4 to the 2nd divided by 4 to the 3rd. 4 to the 2nd, 4 times 4. 4 to the 3rd, 4 times 4 times 4. Wherever we have a top and a bottom that are the same, we can cancel out. This cancels, and this cancels. Now we're left with nothing on top but a 4 on bottom. When we have a number on the bottom of our fraction and nothing on top, we would write that as 1 over 4. We could write 1 over 4 to the 1st power, or 1 over 4. Or we could write that as 4 to the negative 1. We get negative 1 when we do 2 minus 3. So here's the rule. If we have a base to a power divided by the same base to a different power, all we have to do is subtract our powers. Top minus bottom. So like above, when we multiplied, we added our exponents. This time we are going to subtract exponents, keep base. The base is always going to stay the same. All right, we're going to look at one more property of exponent. There are more properties than this, but these are the important ones for today. All right, we're going to raise a power to a power. If I have 6 to the 3rd power to the 2nd power, let's start with our inside parentheses. 6 to the 3rd power is going to be 6 times 6 times 6, 3 times. But I'm taking this power applies to this box, this parenthesis box, which means that I'm taking everything inside and multiplying it by itself twice. So this is the box. So I'm going to multiply 1, 2, 3. Here we have 1, 2, 3, 4, 5, 6. I have 6 6s. And we can get that by multiplying our powers. 3 times 2 gives us 6. Same thing here. I have 2 to the 4th power in my box, and then I'm raising that whole box to the third power. So I have 2 4 times, so here's 2 once, twice, 3, 4 times. And I have 3 of these boxes. So there's 1, 2, 3. Now if I count up all my 2's, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We could also get that by multiplying 4 times 3. So here's the rule. We have a base to a power in parentheses. We raise the parentheses, the whole thing, to another power. To get that, we're going to keep the base and multiply the powers. X times y. In short, we multiply powers and keep the base. Long story short, keep the base for all of these. All right, I know this video is running a little bit long, so let me try to wrap up this last piece fairly quickly. Let's do some practice with multiples of these. All right. Here we have an example of one. We have 3 to the 4th power times 3 to the negative 2nd power, and all that's in parentheses, to the negative 3rd power. Here we're multiplying the same number, same base, different exponents. So multiplying with the same base, we add exponents and keep the base. So I'm going to do these inside first. We're going to add our exponents. So we have 4 minus 2. We could do this as 4 plus negative 2. And it's the same. 4 minus 2 is going to give us 2. So this is 3 to the 2nd power. So we have 3 to the 2nd power to the negative 3rd power. When we raise a power to a power, our rule is to multiply your powers and keep the base. So we're going to multiply 2 times negative 3. Two times 3 is 6. And because we have a positive and a negative, remember from last year, different signs, negative answer. So this we could simplify as 3 to the negative 6. Next we have 4 to the 6th power times 4 to the n equals 4 to the 11th power. Interesting. N. We have to solve for n in this scenario. We are multiplying the same base with different powers. When we do that, we add our exponents, which means that 6 plus n equals 11, because we have to add our exponents together. So if I want to know what n is, I have to undo some things. I'm going to subtract 6 from both sides. If you remember last year, we did this. 6 minus 6 cancels. 11 minus 6 gives us 5, so n equals 5. 4 to the 6th times 4 to the 5th. 6 plus 5 is 11. All right, last one, I promise. 3 to the 7th divided by 3 to the 4th raised to the 2nd power. We're going to start inside the parentheses. When we are dividing with the same base, we subtract our exponents. So we're going to do 7 minus 4 7 minus 4 is 3, so 3 to the 3rd power. And we are raising that to the 2nd power. When we raise a power to a power, we multiply. So we're going to multiply 3 times 2, which equals 3 to the 6th power. All right, go ahead and jump into practice for 2.1 and let me know if you have any questions.